Addressing AFCI breaker tripping issues requires a systematic approach, focusing on potential causes and effective solutions. Firstly, consider the outdoor receptacles. A common issue is the inappropriate use of AFCI breakers for outdoor circuits. AFCIs are primarily designed to detect arc faults within a home's wiring and are not typically required for outdoor receptacles, where ground fault circuit interrupters, or GFCIs, are more suitable to protect against electrical shock. It may be prudent to replace the 20-amp AFCI breaker with a standard non-AFCI breaker for the outdoor receptacle circuit. However, ensure that ground fault protection is maintained by keeping the GFCI receptacle. If nuisance tripping continues, a grounding issue might be present. Verify that the outdoor receptacles are properly grounded. Loose or damaged ground connections can cause unwanted tripping of the breaker. Use a multimeter to check the ground connection's integrity. The resistance between the ground wire and the neutral or hot wire should be very low, ideally close to 0 ohms. Also, the GFCI outlet itself could be faulty. Water seepage into the outlet can cause false trips. Replace the GFCI outlet with a new, high-quality one, ensuring it is weather-resistant and suitable for outdoor use. Secondly, let's talk about bedroom circuits. The configuration of having 2 bedrooms on a single 20-amp circuit can lead to overloading, especially in modern homes with numerous electronic devices. The recommended solution is to divide the 2 bedrooms onto separate 20-amp circuits. This eliminates potential overloading and provides each bedroom with dedicated power. Consult the National Electrical Code, specifically Article 210.21, regarding the permissible load on branch circuits. If splitting the circuits isn't immediately feasible, identify the cause of the potential overload. Determine the source of excessive amperage draw. This could be due to high-power appliances, such as space heaters or window air conditioners, or multiple devices plugged into the same outlet. Use an ammeter to measure the current draw of various devices to pinpoint the culprit. Thirdly, consider the issue of water entry. The tripping of the AFCI when water is near the GFCI suggests a compromised enclosure or wiring. Ensure that the GFCI outlet is installed in a weatherproof enclosure designed to prevent water entry. The enclosure should be tightly sealed and specifically rated for outdoor use, complying with NEMA 3R or higher standards. Inspect the conduit connecting the GFCI outlet to the electrical panel for any damage or loose connections that could allow water to seep in. Seal any openings or cracks with silicone caulk or electrical sealant to prevent water ingress. Furthermore, electrical faults within the wiring can cause AFCI breakers to trip. Schedule a qualified electrician to thoroughly inspect the electrical wiring in the affected areas for any damage, loose connections, or shorts. They should use an insulation tester, also known as a megameter, to check the insulation resistance of the wires. Low insulation resistance indicates a potential fault. Listen carefully for any crackling or buzzing sounds while using appliances or equipment connected to the circuit. Arcing can cause AFCIs to trip, as they are designed to detect this specific type of electrical fault. If you hear such noises, immediately turn off the circuit and investigate the source of the arcing. Also, several additional measures should be taken to ensure the problem is properly addressed. Provide the contractor with detailed information about the tripping incidents, including the date, time, and specific circumstances under which the breaker tripped. Accurate and detailed reporting helps the contractor diagnose the problem effectively. Document the problem by taking photos or videos of the tripping incidents and any visible issues with the electrical system, such as water intrusion or damaged wiring. Visual documentation can be valuable in demonstrating the scope and nature of the problem. If the home is under warranty, request an inspection from the contractor to address these concerns. The warranty should cover electrical issues, and the contractor is obligated to rectify any defects or malfunctions. Now, let's delve deeper into the technical aspects of AFCI and GFCI breakers to understand their differences and proper applications. An AFCI, or arc fault circuit interrupter, is designed to protect against electrical fires caused by arc faults. Arc faults occur when electricity jumps between wires or through a damaged wire, creating heat that can ignite nearby materials. AFCIs detect these dangerous arc faults by analyzing the waveform of the current flowing through the circuit. They look for patterns that indicate arcing, such as erratic current fluctuations or high-frequency noise. When an arc fault is detected, the AFCI breaker trips, cutting off power to the circuit and preventing a potential fire. In contrast, a GFCI, or ground fault circuit interrupter, is designed to protect against electrical shock. Ground faults occur when electricity flows through an unintended path to the ground, such as through a person who is touching a live wire. GFCIs detect these ground faults by monitoring the current flowing through the hot and neutral wires of a circuit. Under normal conditions, the current flowing through these wires should be equal. However, if a ground fault occurs, some of the current will leak to ground, creating an imbalance. The GFCI detects this imbalance and trips, cutting off power to the circuit and preventing electrical shock. The National Electrical Code, or NEC, specifies where AFCI and GFCI protection are required. AFCI protection is typically required for circuits that serve living areas, such as bedrooms, living rooms, and dining rooms. GFCI protection is required for circuits that serve wet locations, such as bathrooms, kitchens, and outdoor areas. Understanding the specific requirements of the NEC is crucial for ensuring electrical safety. When troubleshooting AFCI tripping issues, it's essential to consider the age and condition of the electrical wiring. Older wiring may have deteriorated insulation, increasing the risk of arc faults. Similarly, loose connections or damaged outlets can also contribute to AFCI tripping. In such cases, it may be necessary to replace the wiring or outlets to resolve the problem. Furthermore, the type of appliances connected to the circuit can also affect AFCI performance. Some appliances, such as those with universal motors, can generate electrical noise that may mimic an arc fault, causing the AFCI to trip unnecessarily. If you suspect that an appliance is causing the AFCI to trip, try plugging it into a different circuit to see if the problem persists. If the AFCI continues to trip, the appliance may need to be repaired or replaced. Another important factor to consider is the sensitivity of the AFCI breaker. Some AFCI breakers are more sensitive than others and may be more prone to nuisance tripping. If you are experiencing frequent AFCI tripping with no apparent cause, you may want to try replacing the AFCI breaker with a different model or brand. However, it's important to ensure that the replacement AFCI breaker meets the requirements of the NEC and is properly rated for the circuit. In addition to the above, let's explore some advanced troubleshooting techniques for AFCI tripping issues. One technique is to use an AFCI tester. An AFCI tester is a device that simulates an arc fault, allowing you to verify that the AFCI breaker is functioning correctly. To use an AFCI tester, simply plug it into an outlet on the circuit and press the test button. If the AFCI breaker trips, it indicates that the breaker is working properly. If the AFCI breaker does not trip, it may be faulty and need to be replaced. Another advanced troubleshooting technique is to use a circuit tracer. A circuit tracer is a device that allows you to identify the path of a specific circuit within the electrical system. This can be helpful in locating faults or identifying overloaded circuits. To use a circuit tracer, you first need to disconnect the power to the circuit. Then connect the transmitter of the circuit tracer to the circuit breaker and the receiver to the wires you want to trace. The receiver will emit a tone when it is near the wires connected to the transmitter, allowing you to follow the path of the circuit. Also, examining the load calculations for the circuits in question is essential. The NEC provides guidelines for calculating the maximum load that can be safely connected to a circuit. Exceeding the maximum load can cause the circuit breaker to trip, including AFCI breakers. The load calculation should consider the wattage of all permanently connected appliances, as well as the anticipated load from portable appliances. For example, a 20 amp circuit at 120 volts can handle a maximum continuous load of 16 amps, which is 80% of the breaker's rating. This translates to 1920 watts. Ensure that the total load on the circuit does not exceed this limit. If it does, redistribute the load by moving some appliances to a different circuit. Furthermore, understanding the different types of AFCI breakers is crucial for selecting the appropriate breaker for a given application. There are two main types of AFCI breakers: branch/feeder AFCIs and combination AFCIs. Branch/feeder AFCIs protect against arc faults in the branch circuit wiring, while combination AFCIs protect against both arc faults in the branch circuit wiring and series arc faults in cord-connected appliances. Combination AFCIs are generally recommended for new installations, as they provide more comprehensive protection. It's also vital to consider the impact of surge protectors on AFCI performance. Surge protectors are designed to protect electronic devices from voltage spikes, but they can sometimes interfere with AFCI breakers. Some surge protectors generate electrical noise that can cause AFCIs to trip unnecessarily. If you are experiencing frequent AFCI tripping after installing a surge protector, try disconnecting the surge protector to see if the problem resolves. If it does, you may need to replace the surge protector with a different model or brand. In addition, consider the environmental factors that can affect AFCI performance. Moisture, humidity, and temperature fluctuations can all contribute to electrical faults and AFCI tripping. Ensure that electrical connections are properly sealed and protected from the elements. Use weatherproof enclosures for outdoor outlets and consider using moisture-resistant wiring in damp locations. Regular electrical inspections are also important for maintaining electrical safety and preventing AFCI tripping issues. A qualified electrician can identify potential problems before they lead to faults or tripping breakers. Inspections should include a thorough examination of the wiring, outlets, circuit breakers, and other electrical components. The electrician can also perform tests to check the integrity of the grounding system and the insulation resistance of the wiring. If you are unsure about any aspect of electrical troubleshooting or repair, it is always best to consult a qualified electrician. Electrical work can be dangerous, and improper wiring can lead to fires or electrical shock. A qualified electrician has the knowledge, skills, and experience to safely and effectively diagnose and repair electrical problems. Remember, electrical safety is paramount. Always take precautions when working with electricity and never attempt repairs that you are not qualified to perform. By following these guidelines and seeking professional assistance when needed, you can ensure a safe and reliable electrical system. Also, when discussing the issues with the contractor, focus on clear and concise communication. Clearly explain the symptoms you've observed, such as when the breaker trips, what appliances were in use, and any environmental factors that might be relevant. Provide the documentation you've gathered, including photos or videos of the tripping incidents. Ask the contractor to explain their troubleshooting process and the steps they will take to resolve the problem. Be sure to get a written estimate for the cost of repairs before any work is performed. This will help prevent misunderstandings and ensure that you are aware of the financial implications of the repairs. Also, be proactive in following up with the contractor to ensure that the repairs are completed in a timely and satisfactory manner. If you are not satisfied with the contractor's work, document your concerns and discuss them with the contractor. If you are still not satisfied, you may need to seek assistance from a consumer protection agency or a qualified attorney. The importance of proper grounding cannot be overstated. A properly grounded electrical system provides a safe path for fault current to flow back to the source, tripping the circuit breaker and preventing an electrical shock. The grounding system should be inspected regularly to ensure that it is functioning correctly. The grounding electrode conductor, which connects the grounding system to the earth, should be securely connected and free from corrosion. The ground rods should be driven deep enough into the ground to provide adequate grounding. Also, the National Electrical Code specifies the minimum size and type of grounding conductors that must be used. Make sure that your electrical system complies with these requirements. Another common cause of AFCI tripping is loose connections. Loose connections can create resistance in the circuit, which can generate heat and lead to arc faults. Check all electrical connections in the affected areas to ensure that they are tight and secure. Use a torque screwdriver to tighten connections to the proper torque specification. Replace any damaged or corroded connectors. Also, consider the use of antioxidant compound on aluminum connections to prevent corrosion. Electrical panels themselves also require periodic inspection and maintenance. Ensure that the panel cover is securely fastened and that there are no openings or gaps that could allow moisture or rodents to enter. Check the circuit breakers to make sure that they are properly labeled and that they are not overloaded. Look for any signs of overheating, such as discolored wires or melted insulation. If you find any problems, contact a qualified electrician to make repairs. Also, the proper selection of extension cords and power strips is crucial for preventing electrical problems. Use extension cords that are rated for the intended use and that are long enough to reach the outlet without being stretched or strained. Avoid using multiple extension cords connected together, as this can create a fire hazard. Use power strips with built-in surge protection to protect electronic devices from voltage spikes. Do not overload power strips by plugging in too many devices. It's also important to educate yourself about electrical safety. Learn how to recognize potential electrical hazards and how to respond to electrical emergencies. Teach children about electrical safety and keep them away from electrical outlets and appliances. Install smoke detectors and carbon monoxide detectors in your home and test them regularly. In the event of an electrical fire, evacuate the building immediately and call 911. Do not attempt to extinguish the fire yourself unless you are properly trained and equipped. Finally, remember that electrical safety is an ongoing process. By taking proactive steps to maintain your electrical system and educate yourself about electrical hazards, you can create a safer home for yourself and your family. Periodic inspections, proper maintenance, and a commitment to safety are essential for preventing electrical problems and ensuring a reliable electrical system.